Hey everybody, happy Thursday. Let's go ahead and get started on our Bellringer. Today I want to start with the line plot because this is the problem that is probably the most challenging in this set of problems. First thing I want to do is take a look at the numbers that we have and observe the different formats that they're presented in. 4/5, we would call this a proper fraction. The numerator is less than the denominator. The top number is less than the bottom number. So we can say that that's an amount that's less than 1 whole. It's part of 1 whole. Next we have 3 1/3. This is a mixed number. A mixed number represents an amount that's greater than 1 whole. So in this case, 3 wholes and then a part of a whole, 1/3. Next we have 6/3, which we can say is an improper fraction. It's an amount that's greater than 1 whole. And I know it's greater than 1 whole because the top number, the numerator, is bigger than the denominator. Another thing I want to highlight about this is that because this fraction bar means the same thing as a division symbol, we can rewrite this expression like this. 6 divided by 3, which is 2. So that means that 6/3 has a value of 2, and that will just make it easier to deal with when we're putting it on our line plot. And then next we have 2 4/5, so another mixed number. Okay, so next we're going to take a look at our denominators. We have fifths, which represents 5 equal pieces, thirds, which represents 1 whole divided into 3 equal pieces, and we have fifths again, so 5 equal pieces again, and we're going to have to convert these to like fractions. When I say like fractions, I mean fractions that have a common denominator, making them easier to work with in all kinds of situations. Okay, so like fractions is what we're after here. Make this smaller. Okay, in order to convert these to a common denominator, I'm going to need to find the least common multiple. I'm going to skip count by 5 and 3, and then find the smallest number that's on both of those lists of multiples. Okay, so usually I tell people do like the first 5 multiples, and then if you have to keep going, you could keep going from there. I can see here that 15 is the smallest number that's on both of these lists. Now, I do have numbers on one list that are smaller, like 12 is obviously smaller than 15, but I don't have 12 on this list, so 12 doesn't work. 10 is a smaller multiple, but I don't have a 10 on this list, so 10 doesn't work. 15 is the smallest number that's on both lists of multiples. So I'm going to convert 4/5 to some number out of 15. And I'm going to convert, let's see, 3 1/3. The 3 is going to remain the same, and I'm going to convert that to 15ths. Same for 2 4/5. The 2 will remain the same, and then I'll convert the fifths to 15ths. Okay, so now in order to convert these, I'm going to need to multiply. Always multiply your numerator and your denominator by the same number. So this gives me 12/15. 3 5/15, and 2 12/15. So now I have like fractions. They all have the same denominator, and then of course my 2. So then the last step for you guys is to simply place these values on your line plot, and I'll let you do that on your own. Next, let's do a more simple, straightforward problem. We're going to identify the place value of the underlying digits in this number. 598 and 31 hundredths. The 5 in this number represents or has a value. The 5 represents, let's see, 500, or you could also say 5 groups of 100. And the 3 has a value of 3/10. Notice I'm stating the value of the digit, not its place value position. So in this problem, an answer for the 5, if you put the 5 has a value of, or it's in the hundreds place, I don't want to know what place value position it's in. I want to know the value of the number. Next, we're going to convert 7 2/9 to an improper fraction. Let's think about what 7 2/9 represents. Our 7 wholes can be represented with our good old reliable pizza pies or our pan of brownies. And if I have 7 of these, I can say that I have 7 groups of 9/9, because this one whole, in fraction form, I've divided it into 9 equal pieces. So if I have 7 of them, let's see, 3, 4, 5, 6, 7, I think that's 7. Okay, so there's my 7 groups of 9/9. 7 groups of 9/9 gives me 63/9. Then I'm just going to add my 2/9. 63/9 plus 2/9 gives me 65/9. Okay, next we have a subtraction problem to do. We're going to find the difference between 1 and 6/7. And as always, it's a good idea to start your problem solving with an estimate. Try to come up with a rough idea of what your answer might be. If I imagine that I've made a whole pan of brownies and then I let my little brother eat 6/7 of them, I could kind of predict that I'm going to have a pretty small portion of my brownies left over. So I'm imagining that I have close to, I would say about 1/7 left. That's my estimate. Okay, so now I'm going to take my 1 whole and I'm going to convert that to 7/7. Since I'm working with sevenths in my other number, it makes sense to also change this 1 whole to sevenths to make it easier to subtract. Then I'm going to subtract my 6/7. 7 minus 6 is 1, and my denominator stays the same. I can easily represent this problem with a visual model. So here's a pan of brownies that's been divided into 7 equal pieces. And let's say that little brother has eaten 6/7 of the pan of brownies. When I shade in the 6/7 that little brother has eaten, I can clearly see that I have 1/7 left over. So that one was pretty easy to do. Okay, next we have a volume problem. It asks us to find the volume of a figure that has a length of 10 centimeters, a width of 8 centimeters, and a height of 3 centimeters. The formula or system that I'm going to use to find volume is to multiply length times width times height. So this you can do on your own. This should be pretty easy for you to solve on your own. Once you've figured out the volume by multiplying those 3 numbers together, remember to include your unit in cubic centimeters. Volume is always represented in cubic units, and in this case, the unit of measurement that I'm using is centimeters. Okay, last problem, guys. We're going to convert 36 gallons to some number of quarts. Helpfully, underneath here, we have a reminder that 1 gallon is equivalent to 4 quarts. So we're going to multiply our 36 gallons times 4 quarts because a gallon is bigger than a quart. So that's horse to fly, multiply. Go ahead and multiply that and find your quarts. And then for this one with our kilograms, 12 and 45 hundredths of a kilogram, we need to figure out how many grams that is equivalent to. A kilogram is bigger than a gram. So that's another case of horse to fly, multiply. We're going to multiply 12 and 45 hundredths times the number of grams in a kilogram. There are 1,000 grams in a kilogram. Anytime you see this root word, kilo, you should assume that it represents 1,000. So you're just going to multiply this number times 1,000, which you can do by moving your decimal point over 3 spots to get your number of grams.